Okay, question number 21. The brake on a 15 many Newton car exerts a stopping force of 640. The car's velocity is from that to that, and what is the car's initial momentum? So this stopping force here is to trick you, okay? Because remember, we're looking for momentum, right? Initial momentum should be mass times initial velocity. Do we know mass? We don't, but we do know the gravitational force. Remember, gravitational force or the weight equal mg. So in order to find your m, you can use the weight divided by gram, which is 15680 divided by 9.8 equal 15680 divided by 9.8 is 1600. And then you use 1600 multiply the initial velocity, which is 20, and you get A, 32,000. Okay, number 22. A scooter has a mass of 250 kilograms. A constant force is exerted on it for 6 seconds. During the time the force is exerted, the scooter increases speed from 6 to 28. What is the magnitude of the force? So we're going to use the formula we had before. The only thing that we actually have the force in the formula is Ft times m delta v. Okay, we're looking for the F, so you divide by T on both sides. So F equal m delta v divided by T. All you have to do is plug in your number. It's 250 times 28 final velocity minus 6 initial velocity divided by 6 seconds, and put your calculator, you get 916.7, which is 917. Okay. All right, next. Oh. Well, that one's even easier because it asks you what is the change in momentum. Change in momentum is just m delta v, right? So use 250 times 28 minus 6. 250 times 22 is 5,500. So the answer should be B. All right, number 24. A box is initially at rest on a horizontal frictionless table. If a force of 10 Newton acts on the box for 3 seconds, what is the momentum of the box at the end of the 3-second interval? So, remember that momentum, impulse is changing momentum, right? So, impulse is Ft equal m delta v. And then we have the force, we have the time, which is 10 times 3 seconds. Since we're looking at momentum at the end of the 3 seconds, right? You start at 0, initial 0, and then your final is 3. So basically, this is our final momentum, right? So your answer is 30. Number 25. A small car with a mass of 800 kilograms is moving with a velocity. What is the momentum? Even more straightforward. This is the mass, this is the velocity, P equal mv. All right, multiply them together. Next, a glass falling onto a tile floor will likely break. A glass falling onto a carpet floor may not break because the glass has more time in which to stop. True. Reason why? Because the tile floor, remember the momentum is force times T, right? And then the momentum doesn't change, okay? M delta V. The impulse doesn't change. However, if you have longer time, you will create less force when the glass is like hitting the floor. So the more force will make it crack easier, the less force will prevent it cracking. If you have more time and cause the carpet, there are fibers that you don't see, right? So when the thing is falling down, it actually has more time or has cushion to increase the time, so it will decrease the force. Okay? Number 27. Due to less impulse in stopping, a falling glass may not break if it falls on carpet floor. It's the same question. Or less time. Or less impulse. Which is true. Oh, hold on a second. Due to less impulse in stopping. Oh, my bad. It's due to the time, not the impulse. Impulse doesn't change. Okay? Impulse, this part does not change. It's really the time that changed. So this question should be false. I thought it's the same question.